This isn't an ordinary comet, flickering briefly before fading away. This is something far more enigmatic. Its name is 3I Atlas, the third confirmed interstellar object ever detected, and perhaps the most perplexing of them all. The first measurements came quietly, almost unnoticed, from automated telescopes scanning the heavens for moving points of light. At first, astronomers thought they had simply found another icy visitor, perhaps a little bigger than average. But as the data poured in, disbelief began to spread through observatories around the world. The numbers didn't add up. The brightness was too intense. The gravitational effects on nearby objects were too strong. It was as if a mountain the size of a city had appeared in the solar system overnight. Then came the weight estimate, 33 billion tons. The figure echoed through scientific circles like a thunderclap. 33 billion tons, more massive than any comet ever recorded. Imagine an object so heavy that it could outweigh Mount Everest many times over. Imagine that object not anchored to a planet, not drifting lazily in a stable orbit, but slicing through the solar system like a colossal cosmic sledgehammer. That's 3I Atlas. Space agencies scrambled to point their instruments toward this behemoth. NASA's spacecraft adjusted their sensors. ESA's tracking stations fine-tuned their arrays. And silently, across the cold expanse between planets, 3I Atlas kept moving, indifferent, unstoppable, ancient. Unlike a fragile ball of ice, this was a hardened traveler, forged in another star system, perhaps even another galaxy, long before our sun was born. As news of its discovery spread, scientists noticed something else. Its trajectory didn't fully obey expectations. Comets are usually pushed around slightly by the gases they vent as they heat up, like tiny thrusters changing their paths. But 3I Atlas barely flinched. It was so massive that even while venting over 150 kilograms of gas per second, its course remained eerily stable. It was like watching a battleship plow through waves without slowing down. The comparisons to earlier interstellar visitors began immediately. First came 1I/Oumuamua in 2017, small, fast, and strangely shaped. Then 2I Borisov, a more ordinary comet but still interstellar. But 3I Atlas was different. Its weight alone set it apart. It wasn't just bigger, it was orders of magnitude beyond expectations. Statistically, finding such a massive traveler should have been nearly impossible. And yet, here it was. The shock wasn't only scientific, it was almost emotional. Astronomers who had spent their careers studying faint comets suddenly faced an object that defied their intuition. It was as if the solar system itself had been visited by a silent giant, carrying secrets from the edge of time. And what made it even more mysterious were the events that followed its encounter with Mars, events that hinted at something stranger than anyone expected. Weeks after its close approach to the red planet, two new pieces of evidence emerged. They didn't come from distant telescopes, but from robotic explorers on Mars itself. On October 4th, the Perseverance rover, patiently rolling through Jezero crater, pointed its camera toward the night sky and captured a photograph that stunned both scientists and the public. In the image, 3I Atlas didn't look like a comet at all. Instead, it appeared as a glowing, perfectly shaped cylinder, elongated like a silver lantern drifting across the Martian sky. The internet erupted with comparisons to Oumuamua, which had also displayed a strangely elongated form. But this cylinder seemed even more precise, almost engineered. And then came the second shock. Avi Loeb, the astrophysicist known for bold theories, announced that the trajectory of 3I Atlas almost exactly matched the direction of the mysterious WOW signal detected in 1977, the strongest candidate for a radio transmission from extraterrestrial intelligence ever recorded. The odds of such an alignment happening by chance were tiny. For some, this was merely an intriguing coincidence. For others, it was a chilling hint that the cylinder-shaped object photographed from Mars might not be a natural comet at all. As these revelations rippled through the scientific community, a sense of quiet unease grew. What exactly was this object? How could something so massive appear so suddenly? Why did its path align with a decades-old cosmic mystery? And perhaps most unsettling of all, why did it seem to be ignoring some of the fundamental rules that govern the movement of comets? For now, 3i Atlas continues its silent journey, gliding through the solar system like a ghost ship under starlight. Each telescope trained on it captures only fragments of its story, glimpses of a traveler from the deep. But one thing is clear, this is no ordinary visitor. This is an interstellar enigma, wrapped in mass, mystery, and the cold light of distant stars. Imagine the solar system as a tranquil sea. For billions of years, it has known the gentle rhythm of familiar objects, the planets in their measured orbits, the comets that visit like clockwork, the asteroids quietly drifting in their lanes. And then, suddenly into this calm enters a storm, not of light or sound, but of sheer, unimaginable mass. 33 billion tons. The number hangs in the air like a riddle. Scientists checked and rechecked their calculations, convinced at first that some error must have crept in. But every telescope, every radar sweep, every careful observation came back with the same conclusion. 3i Atlas was not a fragile snowball. It was a titan. To understand just how strange this is, imagine this object approaching our solar system from the darkness of interstellar space. Its size, over 5 kilometers in diameter, would already make it imposing. But its mass takes it to another level entirely. If you were somehow able to place it gently on Earth's surface, it would crush the crust beneath it like thin ice under a falling star. Its gravity, while not planetary, would still be powerful enough to subtly tug on nearby spacecraft. Even from millions of kilometers away, its presence could be measured in tiny shifts in trajectories, like the faint pull of a hidden leviathan beneath still waters. And yet, despite this enormous weight, 3i Atlas moved with eerie grace. It cut through space without hesitation, following a path that brought it unexpectedly close to Mars. Astronomers around the world watched as it swept past the red planet in a silent near flyby, leaving behind questions that had no easy answers. This was not supposed to happen. Statistically, some researchers began to suspect that our models of interstellar space might be wrong, that perhaps massive objects like this are more common than we think, hiding in the darkness between the stars. Others whispered about stranger possibilities, that 3i Atlas might not be a natural fragment at all, but something ancient and constructed, a derelict drifting through the galaxy for eons. These speculations remained at the fringes of scientific debate, but the sheer scale of the anomaly gave them an unsettling weight. Beneath the excitement and the mystery lay a simple, profound question: how could something like this exist? To answer that, scientists began to look at the numbers in more detail. The first anomaly they found was statistical. Based on current surveys, the probability of encountering an object this massive should have required scanning millions of cubic astronomical units of space for decades. And yet, here it was, practically on our celestial doorstep. The second anomaly came from its physical behavior. Ordinary comets are light enough that when sunlight heats their surfaces, gases escape, creating jets that act like tiny thrusters. This causes subtle but measurable deviations in their paths, what astronomers call non-gravitational acceleration. 3i Atlas, however, seemed to ignore this effect entirely. It was venting gas at a rate of 150 kilograms per second, a furious outgassing that should have pushed it slightly off course. But the trajectory remained steady, almost defiant. The explanation, once again, led back to its mass. It was simply too heavy to be nudged. The forces that would have sent an ordinary comet veering slightly sideways barely made a dent in its course. This was like watching a feather try to move a boulder with its breath. This behavior wasn't just unusual, it was almost unnerving. Comets are supposed to be predictable in their unpredictability. Their wobbles and shifts are part of their charm, evidence of the chaotic physics at play as they heat and spin. But 3I Atlas behaved with the steady persistence of something far more solid, far more deliberate. It was during this period that comparisons with Oumuamua grew sharper. Oumuamua had baffled scientists with its strange acceleration and shape, but at least it was light and fast. 3I Atlas was slow, massive, and unyielding. If Oumuamua was like a dart flicking past us, 3I Atlas was a colossal hammer sailing through the void, impossible to ignore, impossible to dismiss. The debate grew intense. Some argued that 3I Atlas was simply an outlier, a rare but natural object, flung from some distant star system billions of years ago. Others believed that the statistical odds were too slim, that this might be evidence of processes we had never observed before, perhaps even technologies we couldn't yet understand. No consensus emerged, but one thing was clear: whatever 3I Atlas was, it had already rewritten the textbooks. And as telescopes continued to monitor it, more unsettling details came to light. Spectral analysis showed unusual chemical compositions, strange ratios of carbon dioxide and industrial-like metals that didn't quite fit with known cometary models. Some of these signatures were so extreme that they hinted at origins in regions of space far colder than any place in our own system. If that were true, then this object might have been born not just before our Sun, but before the Milky Way itself took its current shape. The mass anomaly, the statistical impossibility, the chemical oddities, all of these began to weave together into a single, haunting picture. 3I Atlas was a messenger from a place and time utterly alien to us. Its presence was like finding a perfectly preserved relic from an ancient civilization buried beneath layers of cosmic dust. For now, the scientific community watches and waits. Instruments around the solar system are collecting data. Rovers on Mars have taken photographs. Spacecraft are listening for faint echoes, scanning for radio signals, measuring every flicker of light reflected from its strange surface. And above it all, 3I Atlas sails on, a silent colossus moving through the night. There's a certain comfort in believing that the universe follows predictable rules. Gravity pulls, light travels, heat causes ice to evaporate, and comets dance to this rhythm like fragile travelers briefly illuminated by the sun's warmth. For centuries, astronomers have studied these movements and built elegant equations to describe them. And yet, every once in a while, something appears that moves to a rhythm all its own. 3I Atlas is one such object. Its enormous mass doesn't just make it unusual, it changes the entire way it interacts with the forces of space. Normally, a comet's journey can be thought of as a delicate ballet between gravity and outgassing. As a comet nears a star, frozen gases inside begin to sublimate, turning from solid to vapor and escaping into space. This creates faint jets that act like miniature rocket engines, pushing the comet in unpredictable directions. These pushes are tiny, but because comets are usually so light, they can add up. Astronomers account for this by calculating non-gravitational accelerations to predict their paths. But when scientists applied these same calculations to 3I Atlas, the results were startling. The expected wobbles and deviations were nowhere to be found. It was as if this colossal traveler simply ignored the subtle whispers of physics that normally nudge comets off their paths. Imagine throwing a leaf into a gentle breeze, it drifts, swirls, changes course easily. That's what most comets are like. Now imagine throwing a solid iron spear through that same breeze. The air may swirl around it, but the spear doesn't care. It keeps going straight, heavy and unstoppable. That's 3I Atlas. Even as it vented streams of gas powerful enough to propel a small spacecraft, its trajectory held steady. It didn't flutter, it plowed forward like a massive ship cutting through fog. Astronomers watched in awe as calculations that worked for every known comet seemed to fail here. They adjusted models, added variables, recalibrated instruments, but the conclusion remained the same. The object was too heavy to be affected in any significant way. This led to a nickname whispered half-jokingly in a few observatories: the cosmic sledgehammer. It wasn't meant to be poetic. It was a reflection of the object's sheer physical reality. If Oumuamua had been like a mysterious dart, 3I Atlas was a colossal hammerhead moving through the solar system, reshaping expectations with each kilometer it traveled. The sledgehammer analogy didn't end there. When scientists simulated its encounter with the solar system, they found something fascinating. As it approached, the gravitational influence of planets like Jupiter and Mars tried to tug at it, subtly bending its trajectory. But because of its vast inertia, the deflection was minimal. In some simulations, it passed through the planetary region almost as if the planets were pebbles in a stream, barely altering its cosmic course. This was unprecedented for an interstellar object. Such behavior has profound implications. If more objects like 3I Atlas exist, it suggests that the solar system isn't just occasionally brushed by tiny wanderers. It may sometimes be crossed by silent giants whose presence is almost impossible to detect until they're already close. These are not fragile visitors that can be easily perturbed or deflected. They are ancient travelers, their paths carved across millions of years and countless star systems, immune to the petty gravitational squabbles of planets. It also raises questions about where such an object could have formed. The mass and density implied by its trajectory suggest a birthplace in an extremely cold, distant region, possibly near the edge of another star's or cloud, or even in the vast interstellar gulfs between stars. Over billions of years, it might have been ejected during a chaotic encounter, flung into the darkness like a stone skipping across a frozen lake. For eons it drifted, cold and silent, until fate carried it into our cosmic neighborhood. But as scientists admired the elegance of its movement, they also felt a growing unease. If an object of this scale were ever to pass closer to a planet, the effects could be significant. Even without colliding, its gravitational pull could subtly alter orbits, destabilize smaller bodies, or shift asteroid paths. Thankfully, 3I Atlas posed no immediate danger. Its trajectory would take it past Mars and eventually out toward Jupiter's orbit. Still, the very fact that such a massive traveler could arrive almost unnoticed until it was already nearby was a humbling reminder of the solar system's vulnerability. Meanwhile, the comet's behavior continued to puzzle researchers. Its coma, the glowing cloud of gas and dust surrounding it, was surprisingly faint for an object venting so much material. This suggested that its surface might be unusually smooth or composed of materials that didn't easily produce visible dust. It wasn't the chaotic, glittering halo of a typical comet, but a restrained, almost muted glow, like distant starlight reflected off polished stone. Telescopes picking up its light curve noticed a peculiar steadiness. Normally, as comets spin, their brightness fluctuates because jets fire from different areas, creating uneven illumination. But 3I Atlas remained oddly consistent, as if its rotation was slow, or its shape was remarkably regular. That regularity became one of the strangest clues of all, hinting that the object might not be a rough, tumbling boulder, but something far more uniform. This is where the mystery deepened. If the object's shape was highly regular, say, cylindrical or disc-like, it could explain the even brightness and stable path. But natural objects rarely form such perfect geometries, especially after billions of years drifting through interstellar space. So when the Perseverance rover captured its now famous photograph on October 4th, showing what looked like a glowing cylinder against the Martian sky, many scientists were prepared for controversy. Still, before reaching that moment, the central fact remained: 3I Atlas moved like nothing we'd seen before. It shrugged off the delicate forces that normally guide comets, acting instead like a massive, deliberate traveler, ancient, implacable, and breathtakingly strange. And as night falls on Earth and telescopes continue their silent vigil, one can almost imagine it out there in the darkness, carving through the void like a colossal hammer through silk, indifferent to the tiny forces that try to nudge it aside. The night sky has always held secrets, but few have struck such a strange balance between familiarity and impossibility as 3I Atlas. Watching it drift past Mars with such composure was like observing an ancient ship glide silently through a modern harbor, something old and vast moving through a world that had long forgotten its kind. Astronomers could calculate its orbit, measure its brightness, analyze its spectrum, and yet still they couldn't quite describe it in terms that felt comfortable. Part of the discomfort came from comparisons. Just a few years earlier, humanity had experienced its first brush with an interstellar wanderer, Oumuamua. That discovery had already challenged scientific expectations. Oumuamua was tiny compared to 3I Atlas, only about 100 meters long, but its strange shape and inexplicable acceleration had caused shockwaves through the astrophysics community. It moved too fast, spun oddly, and seemed to be propelled by forces that couldn't be fully explained by simple outgassing. Some speculated it was a fragment of a shattered planet, others that it was a thin, solar sail-like object drifting between stars. But Oumuamua, for all its mysteries, had one important quality: it was small. Its lightness made its odd movements at least theoretically explainable, even if the exact mechanisms remained debated. It was a cosmic puzzle piece that didn't fit perfectly, but it was still a piece that could be turned over, examined, and theorized about. 3I Atlas, on the other hand, was like discovering an entire cathedral where you expected a single brick. New measurements confirmed the staggering truth. Its core was up to 5.6 kilometers in diameter, and its estimated mass was at least 1,000,000 times greater than Oumuamua's. That number alone changed everything. Finding one Oumuamua-sized object had been a stroke of cosmic luck. Finding another interstellar object so soon had been surprising. But finding one this massive so quickly was beyond statistical expectations. Astrophysicists like Avi Loeb began to emphasize this point in interviews and papers. According to existing models, for every massive object like 3I Atlas, there should be hundreds of thousands, perhaps millions, of smaller interstellar fragments drifting through space. Our telescopes should have detected many of these by now if such giants were truly out there. But we hadn't. Instead, we'd found a single anomalous behemoth, arriving like a ghost ship out of nowhere. It was as if you walked along a quiet beach expecting to find a few pebbles, and instead stumbled upon a colossal monolith buried in the sand, gleaming under the moonlight. The odds didn't match the reality. Something was off. Oumuamua had been fast, light, and evasive. It passed by Earth quickly and was gone before most telescopes even had a chance to lock onto it. Its brief visit left behind tantalizing questions, but its behavior was at least fleeting, like a spark in the darkness. 3I Atlas was different. Its immense mass made it slower, easier to track, and far more physically imposing. It wasn't a spark. It was a presence. When scientists plotted its trajectory, they were struck by its steadiness. Oumuamua's path had curved slightly, perhaps nudged by outgassing or sunlight pressure. But 3I Atlas traced a clean, unwavering arc through the solar system, like a massive spear thrown with perfect precision. And because of its size, telescopes around the world and in orbit had weeks, even months, to observe it closely. The more data they gathered, the stranger it became. Its reflectivity was lower than expected, hinting at a dark, possibly carbon-rich surface. This darkness wasn't unusual for comets, but combined with its smooth light curve, it painted a curious picture: a large, dark, regular object moving with eerie stability. Some astronomers proposed that 3I Atlas could be the remnant core of a shattered supercomet, a body formed far from any star, composed of exotic ices and rock, surviving intact for billions of years before being flung into interstellar space. Others pointed to the possibility of gravitational slingshot events near massive stars or black holes, which could launch such objects across galaxies like cosmic bullets. But a small group, including Loeb, pushed the envelope further. They argued that the combination of its mass, shape, and improbable discovery pointed to something more than chance. Perhaps this was evidence of interstellar technology, not active, but ancient. A derelict probe, a fragment of a structure, a vessel from a civilization so old that its creators might have vanished before Earth itself had formed. These ideas were, of course, controversial. Mainstream science remained cautious, emphasizing natural explanations first. But in the quiet corners of scientific discussions, the possibility lingered, subtle and unsettling. Meanwhile, public fascination exploded. Oumuamua had already captured imaginations in 2017, inspiring books, documentaries, and endless debates. But 3i Atlas had all of that mystery amplified by size and presence. It was visible to some amateur astronomers through mid-sized telescopes as a faint moving dot. Social media filled with speculative images and simulations, some accurate, many wildly fantastical. For the first time, humanity wasn't just watching a strange object pass by. It was watching a giant pass by. This comparison to Oumuamua revealed something profound. The solar system is not a sealed sanctuary. It is more like a crossroads, where ancient travelers occasionally drift through, silent and indifferent. Some are small, quick, and easy to miss. Others, like 3i Atlas, arrive like vast ships, carrying with them the weight of distant epochs and places. Each one is a message written not in language, but in physics, their mass, shape, and movement telling us stories we are only just beginning to understand. As the weeks went by, the scientific community's focus sharpened. The object's sheer improbability meant that every new piece of data mattered. Telescopes scanned its surface composition, space agencies prepared their deep space assets to track it near Jupiter, and theorists debated endlessly about what its existence implied for our understanding of interstellar space. And somewhere, far from all the chatter and calculations, the object itself drifted on, unchanged. Silent. Enigmatic. Massive. A ghost from the ancient dark, passing briefly through our sunlit realm before returning to the deep. As the object sailed farther from Mars, slipping deeper into the outer regions of the solar system, the frenzy of early observations slowly gave way to something quieter, more contemplative. At first, 3i Atlas had been a scientific shockwave, a burst of surprise that echoed through laboratories and observatories across the world. But now, as more and more data flowed in, astronomers began to see it not merely as an anomaly, but as a kind of relic, a drifting monument from a forgotten time. Comparisons with Oumuamua persisted, not because they answered questions, but because they sharpened them. Oumuamua had been strange, yes, but it had passed quickly, leaving only fragments of data and unanswered riddles. 3i Atlas was lingering, and its very existence seemed to pull at the edges of what scientists thought they understood about cosmic history. If Oumuamua was a whisper, 3i Atlas was a long, unbroken note echoing through the night sky. In some ways, the two objects were like different kinds of messengers. Oumuamua arrived briefly, like a coded signal flashed across a distance, barely noticed before it was gone. 3i Atlas, on the other hand, was like a stone tablet unearthed from beneath the sands of time, heavy, ancient, and filled with markings we didn't yet know how to read. The more researchers studied its composition, the stranger the story became. Using spectral analysis, scientists were able to examine the gases and dust released from its surface as it warmed near the sun. What they found was not the simple chemical signature of an ordinary comet. Instead, the data revealed an unusually high concentration of carbon dioxide, far more than seen in typical solar system comets. There were also traces of exotic compounds and metals in strange proportions, including unusually high levels of nickel that some described as industrial in character. None of this made sense if 3i Atlas had formed in a typical comet nursery like our own Oort cloud. The ratios of these substances suggested formation in an environment of extreme cold, colder than any region near our Sun, and likely colder than most regions around ordinary stars. This implied a birthplace far out in the frozen reaches of another star system, perhaps one that formed differently from O. When researchers tried to estimate its age, they encountered another stunning revelation. Based on isotopic ratios and the degree of cosmic ray exposure recorded in its surface materials, some teams propose that the object could be up to 14 billion years old, roughly the same age as the universe. It's hard to fully grasp what that means. Imagine an object formed in the cold shadows of the infant universe, drifting through interstellar space for eons, passing silently through countless star systems, witnessing the birth and death of suns, the collisions of galaxies, the slow expansion of the cosmos itself, and finally, after billions of years, it enters our solar system, like a silent observer stepping briefly onto a stage it has crossed many times before. The comet's surface likely holds a kind of cosmic archaeology. Each layer of ice and rock preserves clues about the environment in which it was born. The high levels of carbon dioxide indicate a place colder than Pluto's orbit, where volatile ices could condense without evaporating. The presence of exotic isotopes suggests it may have drifted to regions bathed in high-energy radiation, perhaps near Supernova. It's even possible that the object was once part of a much larger body, a supercomet or planetoid, that was torn apart by gravitational forces long ago. What remains now could be its dense, hardened core, preserved like a fossil, carrying within it the frozen chemical memory of a world that no longer exists. As scientists considered this possibility, a strange sense of reverence began to accompany their discussions. 3I Atlas was no longer just a curiosity. It was a witness, a traveler that had seen more of the universe than any spacecraft humanity had ever launched. Its orbit through our solar system was brief, but its story spanned almost the entire age of time itself. And yet, there was another layer to the mystery. If it truly was this ancient, how had it remained intact for so long? The interstellar medium is not entirely empty. It's filled with particles, radiation, and the occasional violent shock wave from distant cosmic events. Over billions of years, most objects are slowly eroded, broken apart, or deflected into new paths. For 3I Atlas to have survived, it must be made of something remarkably strong and stable, a composition unlike the fragile icy conglomerates of most comets. Its resilience hinted at either an extraordinary natural origin or something else entirely. The age estimates fueled speculation. Some astronomers quietly wondered whether this object might have originated in one of the first generations of star systems, perhaps even before the Milky Way settled into its current spiral shape. Others speculated it might have drifted between galaxies, carried by the slow tides of cosmic expansion, eventually captured by our sun's gravity as it passed near the solar system. Whatever its true journey, one thing was clear: 3I Atlas had been traveling for an incomprehensible length of time. Every crater, every scar on its surface told a story we had only begun to decipher. In a sense, studying it was like opening a book written in a language older than stars, each chemical signature a forgotten word, each isotopic ratio a hint of distant landscapes we would never see. As night fell on observatories across Earth, astronomers watched the object through their instruments, knowing they were glimpsing not just a comet, but a fragment of the deep past, a survivor from the dawn of the cosmos, briefly illuminated by our sun before vanishing once more into the dark. For weeks after its closest approach to Mars, the excitement around 3I Atlas had been steadily growing. But nothing, no theory, no simulation, no press release, prepared anyone for what happened on October 4th. That morning, NASA's Perseverance rover was following its usual routine on the dusty plains of Jezero Crater. Its cameras scanned the sky frequently, not because Mars had much to look at, but because this particular week, something unusual was passing nearby: the interstellar comet 3I Atlas, on its outbound trajectory, faintly glowing in the Martian dawn. The rover's automated skywatching program captured a series of long-exposure photographs as the object crossed above the horizon. Later, when the images were transmitted back to Earth and stitched together by mission engineers, one frame in particular caught everyone's attention. It didn't look like a comet. Instead of the soft, fuzzy blur scientists expected, The object appeared as a perfect glowing cylinder, elongated and symmetrical, its structure so clean that many initially thought it was a data error. The shape seemed to stretch across the sky like a bright, metallic rod, gleaming against the thin Martian atmosphere. Within hours of release, the image went viral. Social media erupted. Amateur astronomers zoomed in, enhanced the contrast, and overlaid it with silhouettes of known objects. The comparisons came fast and loud. "It looks like Oumuamua. It's a ship. This isn't a comet." What made it worse, or perhaps more thrilling, was how similar the shape was to Oumuamua's strange, non-cometary geometry. Oumuamua had been described as either a cigar or a flattened pancake. Its irregular light curve hinted at something long and narrow tumbling through space. But here, on Mars, Perseverance had apparently captured something far more defined, almost engineered in its neatness. NASA's official channels were cautious. They released a short statement emphasizing that the image was preliminary, that more data would be needed, and that artifacts from long exposures often produced misleading shapes. But that did little to calm the growing wave of speculation. People remembered how, in 2017, Oumuamua had left the solar system before any spacecraft could get a good look at it. 3i Atlas, by contrast, had flown close to Mars, and we actually had robotic observers there. The idea that Perseverance might have captured something genuinely extraordinary felt electrifying. Inside mission control rooms, discussions grew tense. Some engineers suggested the image was simply a result of motion blur. The comet's rapid movement during the exposure time created the illusion of a cylinder. Others pointed out that the brightness and uniformity of the object were unusual for such an effect. If it were purely motion blur, they argued, the intensity should have faded along its length. Instead, the light was even and sharp, as if reflecting from a smooth surface. A few astronomers, speaking anonymously, admitted their unease. The Mars rover had been deliberately scheduled to photograph 3i Atlas at that exact time, a fact not widely publicized. Why was that? And why did it take nearly 2 days before the raw data from the camera were fully rel? The combination of secrecy and ambiguity was like dry tinder to a wildfire of speculation. Some claimed NASA was hiding additional frames. Others insisted the cylinder was proof of an extraterrestrial probe. Conspiracy forums flourished overnight. But behind the sensationalism, serious scientific questions emerged. Why did the image look so clean? Why was Perseverance pointing there in the first place? And if this was just a comet, why did the data release seem strangely delayed? Astrophysicist Avi Loeb, never one to shy away from controversial topics, was contacted almost immediately. In a calm interview, he explained that the most likely explanation was indeed a camera artifact. Long exposures on a moving object often create unusual shapes, and the cylinder could simply be the result of the comet's path streaking across the sensor. But then he added something that kept the mystery alive. The fact that the rover was instructed to take these images is significant. It means the trajectory and brightness were being tracked carefully. We should wait for the full dataset before making any conclusions. The words, "wait for the full dataset," did little to dampen the growing intrigue. Already, enthusiasts were combing through every Mars orbiter archive they could access, searching for corroborating shots. The European Space Agency confirmed that the Trace gas orbiter had also been observing the flyby, but their data, too, would take time to process. Meanwhile, journalists pressed NASA for clarification. Why hadn't the raw data been released immediately? Why did the published photos seem to have been enhanced? Officials offered bland answers about processing delays and bandwidth limitations, but for many, the timing felt off. By the end of the week, the cylinder on Mars had become a headline. It was more than just a photo now. It was a symbol of the strangeness of 3i Atlas, a moment when a distant, silent traveler had appeared in sharp, impossible clarity on another world's sky, like a cosmic signpost pointing toward deeper mysteries. No one could say for certain what Perseverance had actually captured. But the image lingered in the public imagination, hovering like the object itself, both real and unreal, both explained and unexplained. And somewhere out there, 3i Atlas continued on its path, indifferent to the speculation it had stirred, gliding into the dark beyond Mars as if nothing at all had happened. In the days that followed the Perseverance image release, the scientific world entered a strange state of tension. It wasn't the kind that came with official emergencies or catastrophic discoveries. It was quieter than that. Behind the polished press releases and the measured language of spokespeople, there was the unmistakable sense that something was being managed, carefully, deliberately, and perhaps not entirely openly. NASA and ESA maintained their usual calm posture. They explained that the raw image files from Mars were still being processed, that transmission delays from the rover were typical, and that the glowing cylinder was almost certainly a product of long exposure. The explanation was sound. It was reasonable. It was also, for many, too neat. The Perseverance team had never before delayed the publication of raw Skywatch images for so long. Typically, frames were available within hours. This time, it took nearly 2 full days, and when they did appear, they arrived with annotations, calibration overlays, and a few unexplained gaps in the sequence. Inside certain observatories and university departments, whispers started to circulate. The timing of the image release, the careful framing of the explanation, and the decision to downplay the cylinder's shape all pointed to something more complex happening behind the scenes. Officially, everyone was aligned. It was a photographic artifact, nothing more. Unofficially, some astronomers suspected that NASA and ESA were buying time, perhaps to double-check their data before making any further statements, or perhaps to coordinate with other agencies that had been observing 3i Atlas at the same time. Meanwhile, amateur analysts weren't waiting for the official verdict. Across forums and live streams, they overlaid the Perseverance cylinder with telescope data, matched it against orbital models, and debated fiercely over the details. Some pointed to subtle inconsistencies in the brightness gradient. Others noticed that the supposed artifact was almost perfectly aligned with the comet's axis of motion. It wasn't proof of anything extraterrestrial, of course, but it wasn't easy to dismiss either. The strangeness was like static beneath a clear signal, easy to ignore if you wanted to, but impossible to fully erase. In one particularly revealing press conference, a journalist asked directly why the Perseverance team had targeted that portion of the sky so precisely, and whether they had expected to catch the comet at that exact moment. The response was vague, citing trajectory tracking and scientific opportunity. But several experts noted that the precision of the alignment suggested more than routine observation. It was as if they had been waiting for something. And then, almost as if the universe itself had been listening, another thread surfaced, this time not from Mars, but from Earth. On a quiet afternoon, Avi Loeb published a short but startling analysis. He had been examining the inbound trajectory of 3i Atlas, mapping its path backward through space to determine its possible origin. To his surprise, the direction from which the object had entered the solar system almost perfectly overlapped, with just a 0.6% margin of deviation, the region of sky associated with the WOW signal of 1977. For decades, the WOW signal had been one of astronomy's most tantalizing mysteries, a 72-second burst of radio energy detected by Ohio State University's Big Ear radio telescope. It had matched what scientists expected a narrow-band extraterrestrial transmission might look like, and then it had vanished, never to be repeated. Dozens of explanations had been proposed, from passing comets to satellite reflections, but none were conclusive. Loeb's finding didn't prove a connection, but the coincidence was extraordinary. The WOW signal's origin was a broad patch of sky near the constellation Sagittarius, and 3I Atlas had entered from almost the exact same direction, as if emerging from the same distant corridor of space. The news spread quickly. Within hours, observatories around the world began retuning their radio telescopes to listen along 3I Atlas's trajectory. If there was even a small chance that the object was related to the WOW signal, this was the moment to find out. Scientists were careful with their language. Coincidence does not imply causation, they repeated. This is an interesting alignment, not evidence of intelligence. But outside the walls of academia, the reaction was far less restrained. For many in the public, this was the final puzzle piece. First the mass anomaly, then the bizarre shape, then the secrecy, and now, possibly, a connection to the most mysterious radio signal in human history. Speculation flourished. Some suggested that 3I Atlas wasn't a comet at all but a derelict probe, drifting for millennia between the stars. Others imagined it as a kind of interstellar buoy, transmitting signals intermittently, like a forgotten beacon waiting to be noticed. And yet, beneath the excitement, there was also a sense of something subtler, more profound. If the alignment was real, it meant that 3I Atlas and the WOW signal might share a common point of origin, a place somewhere beyond our local stellar neighborhood, a region of space that, for reasons unknown, had sent us both a mysterious radio pulse and a massive, ancient object. Astronomers began to quietly wonder, what kind of place could produce both? As 3I Atlas continued its silent journey past the orbit of Mars, telescopes on Earth and around the solar system turned toward it. Dishes listened in radio frequencies. Optical instruments traced its faint coma. Infrared sensors scanned for unusual heat signatures. Everyone was searching, hoping, straining for a clue. The cylinder photo had ignited curiosity. The WOW signal connection had turned that curiosity into a quiet, simmering obsession. Something about this comet didn't fit, and every new piece of evidence seemed to draw the circle of mystery tighter. For nearly half a century, the WOW signal had remained a single, unsolved whisper from the cosmos, a fleeting moment of ordered sound amid the endless background noise of the universe. Detected on August 15, 1977, by astronomer Jerry Emin, the narrowband radio signal had lasted just 72 seconds. It was strong, clean, and inexplicably precise. Next to the printout of the data, Emin had circled the string of numbers and letters that marked the peak of the transmission, and in the margin, written one word in red ink: "Wow!" That handwritten exclamation had outlived the telescope itself. Over the decades, scientists had pointed radio dishes back to the same patch of sky countless times, hoping to catch the signal again, but it never returned. It remained a ghostly fingerprint, an unresolved question. Some believed it was a natural phenomenon we simply didn't yet understand. Others suspected extraterrestrial intelligence. But no definitive explanation ever emerged. And now, in the autumn of 2025, that old mystery was suddenly stirring again, not because the signal had reappeared, but because an interstellar object was moving through the solar system along almost the exact same inbound trajectory from which the WOW. The coincidence was electrifying. Within days of Avi Loeb's publication, observatories around the globe coordinated one of the largest ad hoc deep space listening campaigns in recent memory. At Arecibo's successor installations, in giant arrays in South Africa and Australia, and even in smaller university facilities, radio telescopes turned their dishes toward the distant comet, sweeping across frequencies, searching for patterns hidden in the cosmic static. At night, control rooms were bathed in the glow of monitors, their walls alive with scrolling data streams and spectral plots. Technicians whispered, scientists leaned forward in their chairs, and everywhere, there was a palpable sense of shared anticipation. Most of them knew the rational odds. The alignment could easily be a coincidence. But a few couldn't help feeling that they were standing on the threshold of something historic. 3I Atlas itself, drifting outward from Mars, gave no sign that it noticed the attention. It did not flare unusually or emit obvious signals. Its massive cylindrical shape remained a topic of debate, its strange steadiness under outgassing forces still unexplained. But its trajectory was clear. It was passing along a corridor of space that had intersected the WOW. For radio astronomers, this was a rare gift. Normally, searching for extraterrestrial signals involves scanning enormous sections of sky with no clear target. Here, for once, they had a precise direction, a moving beacon to track, and a time-sensitive window to observe it. Some focused on the exact frequency of the original WOW signal, 1420.4556 MHz. The hydrogen line, a natural frequency in the universe, often considered the most likely hailing channel for intelligent civilizations. Others broadened their scans, looking for narrowband spikes, repeating pulses, or drifting tones that might hint at artificial modulation. Nights blurred into days. Servers filled with terabytes of raw data. At SETI facilities in California, young researchers wrote code on the fly to process the influx, their screens filled with waterfall plots and frequency time graphs. They knew the world wasn't watching them live, but they felt its quiet gaze all the same. This was a search not just for a signal, but for meaning, for a thread that might connect an ancient mystery to a modern enigma. Public interest soared. Documentaries replayed the original WOW signal recording, overlaying it with images of 3I Atlas gliding through the darkness. Social media buzzed with speculation, theories, and a fair amount of wild imagination. For a brief moment, the world seemed united in listening, collectively holding its breath, wondering if something out there might whisper back. But as days passed, no clear signal emerged. The data was vast and noisy. There were occasional blips, narrow band spikes that triggered alerts, but each one, upon inspection, turned out to be local interference, satellite transmissions, or natural cosmic phenomena. This was not unexpected. The WOW signal had been a once-in-a-lifetime anomaly. Even if 3I Atlas was somehow related, there was no guarantee that it would be broadcasting anything now. It might be silent. It might never have transmitted at all. Or it might have emitted that fateful pulse thousands of years ago, long before humanity had the means to detect it. Still, the search continued. Late one night at the Meerkat radio telescope in South Africa, an engineer leaned back in his chair, listening to the faint hiss coming through his headphones. He knew it was just the cosmic microwave background, the afterglow of the Big Bang, stretched thin across the universe. But somehow, it felt different that night. The presence of 3I Atlas made even the silence feel charged, as if beneath the noise, something ancient was waiting to be noticed. And perhaps that was the real power of the WOW signal connection. It wasn't proof. It wasn't evidence. But it was a reminder that the universe is vast, strange, and full of echoes we don't yet understand. The alignment between the signal's origin and the comet's path didn't answer questions. It amplified them. Why had the WOW signal appeared once and never again? Why did this enormous, ancient object happen to drift along the same route? Was it coincidence, or was there some deeper cosmic story unfolding across timescales far beyond our comprehension? Scientists prepared to publish early observational results, summarizing the listening campaign. Even without a detected signal, the effort was unprecedented. For the first time in decades, humanity had focused its collective scientific attention on a single mystery, listening together to the quiet between the stars. Meanwhile, 3I Atlas kept moving, slow and indifferent. It had already crossed Mars's orbit and was on a steady course toward the outer solar system, its vast mass gliding through space like a silent celestial ship. Whether it carried messages, secrets, or simply ice and rock, no one could yet say. But the sense of being on the verge of something lingered, like a held breath that no one wanted to release too soon. By early October, the initial storm of excitement surrounding 3I Atlas had begun to settle into something deeper and more reflective. The comet, if comet was even the right word anymore, had passed Mars and was continuing its solemn journey toward the colder, emptier reaches beyond. But the questions it left behind were not fading. If anything, they were growing sharper. Around the world, observatories compiled their data into reports. Telemetry from the Mars rovers, orbital measurements from ESA and NASA spacecraft, ground-based optical observations, and the massive coordinated radio listening campaign, all of it was slowly being analyzed, compared, and cross-checked. What emerged wasn't a neat picture. It was a portrait of contradictions. The first and most striking anomaly was its mass. Based on its gravitational influence and the behavior of gases escaping its surface, 3I Atlas was estimated to weigh around 33 billion tons, an astonishing figure. No other interstellar object detected so far came remotely close. Oumuamua, by comparison, was lightweight, almost fragile. 3I Atlas was a sledgehammer. Its diameter, too, was remarkable, roughly 5.6 kilometers across at the core. That alone wouldn't have raised eyebrows. Comets of that size exist in our solar system, but its mass-to-size ratio implied a density far higher than expected. It was too heavy for a loose ball of ice and rock. It behaved more like a solid metallic object than a typical comet nucleus. Then there was the issue of non-gravitational acceleration. Normally, when comets warm up near the Sun, the jets of evaporating gases act like tiny thrusters, subtly altering their trajectories. 3I Atlas was venting roughly 150 kilograms of gas every second, yet its path remained eerily stable, as though the jets were pushing against a mountain. This could only be explained by its massive inertia, or by some property we hadn't yet identified. Its chemical composition deepened the puzzle further. Spectroscopic readings revealed unusually high levels of carbon dioxide, along with unexpected isotopic ratios and traces of industrial-grade nickel. These findings suggested it wasn't born in any environment resembling our solar system. Instead, its materials pointed to extreme cold, perhaps from the outer regions of another stellar nursery, or even another galaxy entirely. Its shape, captured in that unforgettable Perseverance image, refused to fit expectations. A glowing cylinder, elongated and symmetrical, unlike the irregular forms of known comets. The official explanation pointed to motion blur, and that may very well have been the truth. But the delay in releasing the raw data, the precision of the observation, and the eerie clarity of the image left a lingering unease in the scientific community. And then, like a final thread weaving through everything, came the trajectory coincidence with the WOW signal, that enigmatic radio transmission from 1977. The odds of such an alignment were low. Not impossible, but low enough to make people pause. Each of these elements alone might have been explainable, but together they formed a constellation of anomalies that was difficult to ignore. A massive, ancient, strangely shaped object, an improbable trajectory, odd chemistry, hints of radio mysteries, and an image that refused to be forgotten. In conference rooms and late-night Zoom calls, astronomers debated these puzzles with a mixture of fascination and caution. Some urged restraint, warning against sensationalism. The simplest explanation, they argued, was that 3I Atlas was an extremely rare but natural comet, a statistical outlier that just happened to combine several unusual traits. Others pointed out that relying on statistical outliers to explain so many anomalies at once felt like stacking coincidences on top of coincidences. One particularly striking statistic emerged during these discussions. According to models, to find an interstellar object of this mass and size by random chance, we would have to discover hundreds of thousands of smaller objects first. Yet here it was, only the third known interstellar visitor after Oumuamua and Borisov, and by far the most extraordinary. The list of key questions grew longer with each passing week. Why was 3I Atlas so heavy? How had it survived intact for what might be 14 billion years? What natural process could shape or preserve a cylinder-like structure in deep space? Why did its path matc? The scientific consensus remained cautious. Most researchers lean toward a natural explanation, simply because extraordinary claims require extraordinary evidence, and nothing so far had crossed that threshold. But there was also a quiet recognition that something about this object didn't fit comfortably into existing models. Somewhere between the mass calculations, the spectral analyses, and the endless radio scans, a subtle shift had occurred. 3I Atlas was no longer just a visitor. It had become a mirror, reflecting our own uncertainties, our curiosity, our hunger for connection, and our willingness to confront the unknown. And perhaps that was its greatest gift. Whether comet, relic, or something stranger, 3I Atlas had forced humanity to look up again, not just with instruments, but with imagination. As it slipped farther from Mars, crossing invisible boundaries into the outer solar system, the excitement mellowed into a kind of patient watchfulness. New data was coming. Spacecraft were still tracking it. And somewhere beyond Jupiter, it would soon be met again, this time by instruments designed to see it in a way no Mars rover or Earth telescope ever could. Beyond the orbit of Mars, the solar system begins to change. The sun's warmth fades into a gentle, distant glow, and the spaces between planets stretch wider, like vast corridors leading to the dark. Here, in this silent region, 3I Atlas continues its journey, slow, deliberate, and unstoppable. By this point, ground-based telescopes were beginning to lose their grip on it. Each night, its image grew fainter, blurred by distance and the quiet hum of interstellar motion. What had once been a luminous green visitor dominating headlines and capturing the imagination of millions was now becoming a solitary traveler again, slipping toward the realm of giants, Jupiter, Saturn, and beyond. Yet, even as its visible presence faded, the story was far from over. Behind the scenes, space agencies were preparing for a second act. Instruments aboard ESA's JUICE mission, NASA's Europa Clipper, and several deep space radio arrays were quietly repositioning, recalibrating, and extending their observation schedules. They understood something crucial. What lay ahead might reveal more than anything seen so far. The region near Jupiter acts like a cosmic magnifying glass. The planet's immense gravity bends the trajectories of passing objects, sometimes flinging them outward, sometimes pulling them closer. For 3I Atlas, this meant that its path would bring it into a zone where even small deviations could be measured with exquisite precision. If there were hidden forces acting on it, subtle accelerations, outgassing patterns, or, as some dared to imagine, controlled course adjustments, Jupiter's gravitational field would make those deviations stand out like ripples on still water. Engineers at ESA's Mission Control had already inserted a series of special observation windows into JUICE's schedule. Though the spacecraft's primary mission was to study Jupiter's icy moons, it had powerful instruments capable of scanning passing objects in remarkable detail. If everything aligned just right, JUICE could catch a glimpse of 3I Atlas as it passed T, providing data from a disk. At the same time, a network of deep space radio telescopes on Earth, from the Atacama. The upcoming Jupiter flyby zone offered a chance to listen again, this time under different conditions, with better triangulation and far more sensitive. For the scientific community, this waiting period felt almost like standing on the edge of a cliff at night, staring into a foggy valley below, knowing that something was moving out there, but not yet knowing. Speculative papers began to circulate quietly, sometimes not even published in journals but passed from scientist to scientist, whisper-like. Some proposed exotic natural explanations, primordial rogue planets shattered by stellar tides, fragments of intergalactic icebergs, objects formed before the Milky Way itself was fully assembled. Others dared to ask more radical questions. What if 3I Atlas was not entirely passive? What if it was a relic of intelligence, drifting through time and space like a forgotten message in a cosmic bot. Most scientists remained cautious, as they should. But even among the most conservative voices, there was a shared understanding that this object was different. Not necessarily artificial, but rare enough, old enough, and strange enough that it could stretch our understanding of how the universe builds and preserves its wanderers. Meanwhile, among the public, 3i Atlas had taken on a kind of mythic quality. For months it had dominated news cycles, inspired late-night debates, filled YouTube videos with speculative theories, and drawn millions. People around the world kept watching, amateur astronomers pointing telescopes at the darkening sky, radio hobbyists tuning their equipment to strange frequencies, artists painting their interpretations of the glowing green cylinder, children asking their parents if it would ever come back. In a way, the comet had become more than an astronomical event. It had become a shared mystery, something that briefly united human curiosity across languages, borders, and beliefs. It reminded us that, despite all our technology and our expanding scientific knowledge, the cosmos still holds secrets vast enough to humble us. Somewhere between Mars and Jupiter, 3i Atlas drifts on. Its enormous mass carries it forward like an ancient vessel, indifferent to the whispers it has stirred behind it. It neither slows nor speeds up. It simply moves, following the same path that began long before humans learned to look at the stars and name them. And so we wait. For the spacecraft readings. For the radio echoes. For the unexpected. Because if 3i Atlas has taught us anything, it's that the universe still has stories to tell. Stories that don't fit neatly into categories. Stories that unfold slowly, like a long-forgotten legend written across the night sky. Somewhere, deep in the cold dark, the green glow continues. Silent. Massive. Ancient. Another possibility. It was never bound to a star at all. Some astronomers think that between the stars, there are vast numbers of free-floating comets and planetesimals, thrown out of their birth systems during chaotic formation eras. If that's true, 3i Atlas is not alone. It's just one among countless billions, passing through unseen every year, most too faint for us to ever notice. Then there's the composition mystery. Its coma revealed strong signals of water, but the precise ratio of gases is still being studied. Some early spectroscopic hints suggest unusually high levels of carbon dioxide compared to typical solar system comets. If confirmed, that could mean it formed in an especially cold region, farther out than Pluto's distance would be around its original star. High CO2 levels imply temperatures so low that even this volatile substance could freeze solid. That, in turn, hints at a very specific kind of nursery, perhaps the far edge of a protoplanetary disk around a small, faint star, where the temperature was low enough to preserve fragile ices for billions of years. There's also the question of how long this object has been wandering. Some orbital reconstructions suggest it may have spent billions of years drifting through interstellar space. Out there, between the stars, it would have endured cosmic rays, micrometeoroid impacts, and unimaginable cold. Its surface may be scarred, darkened, and chemically altered. But beneath, deep inside, the original ices could remain pristine, preserving a chemical record of a star system long vanished. Another guess involves its trajectory through our solar system. While its current path is well measured, tiny forces, jets of gas, uneven outgassing, or interactions with the solar wind could cause slight deviations. These small shifts could tell us about its mass, shape, and activity. For Oumuamua, non-gravitational accelerations were one of the great surprises. For 3i Atlas, scientists are watching carefully to see whether similar subtle pushes occur. If they do, they can reveal details invisible even to the best telescopes. Then there's the frequency of objects like this. 3 interstellar visitors in less than a decade, Oumuamua, Borisov, and now Atlas, suggest that the galaxy may be full of such wanderers. But the sheer size of 3i Atlas, if its upper estimates are correct, makes it a statistical outlier. Finding something this big so soon is unexpected. One guess is that our surveys have only just become sensitive enough to notice them. Another is that the solar system happens to lie near a rich stream of interstellar debris, perhaps released from a distant stellar nursery long ago. A more speculative idea, maybe interstellar comets are not rare at all. Maybe we've simply been blind to them, and Atlas is the first of many giants we'll detect now that telescopes like Vera Rubin Observatory are coming online. If so, the night sky may soon become far busier, with ancient visitors slipping silently through the solar system more often than we ever imagined. And what of its internal structure? No probe will visit 3i Atlas, but astronomers can make guesses. If its density is low, like many comets, it might be a loose pile of ice and dust, held together by gravity alone, a cosmic snowball the size of a mountain. But if its density is higher, perhaps due to rocky or metallic material, that would change its mass estimates dramatically. That's why the 33 billion tons figure floats around. It depends entirely on what you assume is inside. Some researchers quietly wonder whether ancient interstellar objects could carry minerals or isotopic signatures not found in our solar system. If a fragment like this were ever captured and studied up close, it might rewrite parts of our understanding of cosmic chemistry. The timing of its arrival also raises questions. Was this pure coincidence, one comet among trillions crossing paths with our star, or part of a larger pattern of interstellar objects drifting through in waves? Our observations are still too sparse to say. But every object like Atlas gives us one more data point, one more clue. And finally, there's the future. After it swings past the Sun, 3i Atlas will leave again, heading back toward the interstellar void. But its visit may mark the beginning of a new era. We now know how to detect such objects early. In time, we may even be able to intercept one, sending a fast spacecraft to study it up close, to touch a fragment of another star's history. For now, though, it remains what it has been for untold ages, a solitary traveler, carrying secrets from a place we may never see, whispering through the solar system before vanishing once more into the dark. The comet is still out there, drifting beyond the bright glare of the sun. For now, 3i Atlas is silent to our telescopes, hidden in that blinding corridor of light where Earth's instruments dare not look. But astronomers are waiting. Across observatories and control rooms, there's a quiet sense of anticipation, like the hush before a theater curtain rises again. When it re-emerges from behind the sun, it will be greeted not just by telescopes on Earth, but by an entire fleet of watchers scattered across the solar system. Mars orbiters have already locked their instruments toward the point in space where it will appear. The Trace Gas Orbiter and MRO have been collecting every hint they can, even during the blackout. Soon, their stored data will begin to flow home, like messages carried back from a distant frontier. And then, further ahead, something more ambitious is planned. In 2026, the JUICE spacecraft, currently en route to Jupiter, will turn its powerful cameras toward 3i Atlas. It won't intercept the comet, but its vantage point near the giant planet will give us a perspective no Earth telescope could ever achieve. For a brief window, JUICE will see the object framed against the darkness of interstellar space, illuminated by the sun's distant glow. Scientists are quietly excited. If JUICE's instruments can catch even a handful of high-resolution images, they might reveal the texture of its surface, the ridges, the fractures, perhaps even the strange cylindrical silhouette that Mars captured for only a moment. Spectrometers might detect the precise fingerprints of its chemistry, teasing out secrets frozen since before our solar system existed. There's also talk of listening. Some radio astronomers are preparing to turn their arrays back toward the comet's direction, following Avi Loeb's suggestion. They don't expect to hear a voice from the stars, but they're listening all the same. Just as sailors once tuned their ears to the wind, modern astronomers tune their antennas to the faintest whispers in space, waiting for something unusual to hum through the static. Meanwhile, theoretical models are running in the background of powerful computers, Each model is like a story written in mathematics. What if it came from a dying star? What if it passed near a black hole? What if it's part of a larger stream of interstellar objects? Thousands of scenarios are played out, simulated in silence, as scientists try to unravel the path this ancient traveler took before arriving here. Some of those scenarios are unexpectedly poetic. One model suggests that 3I Atlas may have wandered for so long that it has circled the galaxy several times, like a moth endlessly looping through the night. In those billions of years, it may have passed close to countless stars, brushed through alien Oort clouds, and witnessed the rise and fall of entire planetary systems. Its surface, darkened by cosmic rays, might carry faint scars from those encounters, invisible to us, but recorded in its molecular structure like forgotten inscriptions. Another model suggests something even more delicate. If the comet truly formed in the coldest outskirts of a small, ancient star system, then its interior could still hold perfectly preserved ices from that time. Trapped inside, untouched by radiation, they may contain chemical ratios from the dawn of the galaxy, a kind of frozen message from the earliest days of star formation. If humanity is wise, future missions might not just observe such objects, but chase them. Some dream of a day when a rapid response spacecraft could be launched the moment an interstellar visitor is detected, racing across the solar system to meet it before it vanishes again into the dark. Such a mission would be like sending an explorer to greet a passing messenger from another civilization, or another epoch. For now, though, 3I Atlas drifts on, unaware of the excitement it has sparked. Its orbit carries it slowly toward the outer planets. Beyond Jupiter, it will grow fainter with each passing week, until only the most powerful telescopes can catch its trace. And then, one day, even they will lose it, and it will fade back into the cosmic sea from which it came. But its brief visit has left a mark. Astronomers have seen something they didn't expect, a giant interstellar traveler that doesn't behave like anything they've studied before. Whether natural or not, 3I Atlas has become a kind of cosmic riddle, a mystery written in ice and motion, crossing our path only once in all of human history. And somewhere, out beyond the planets, in the cold silence between the stars, the comet continues its journey, ancient, patient, and full of secrets it has yet to reveal. Imagine the space between stars not as a void, but as an ancient, cold epochs. Stretches of time so vast that entire civilizations could rise and vanish before it reaches its next star. Scientists sometimes speak of interstellar comets as time travelers. Their ices are older than any planet, their surfaces etched by a history that no telescope can fully read. Deep inside 3I Atlas, shielded from radiation, may lie pockets of pristine material, molecules formed in the earliest clouds of the Milky Way. Studying them would be like opening a bottle tossed into the cosmic tide billions of years ago, finally retrieved by curious hands. To understand what this means, astronomers turn to spectroscopy. Every element and molecule leaves its own delicate signature in the light that bounces off the comet. By breaking that light into its rainbow of wavelengths, scientists can read the hidden language of its chemistry. Already, early observations hint at a strange balance of gases, unusually high carbon dioxide, faint traces of carbon monoxide, and perhaps complex organics. These clues suggest that 3I Atlas formed far from the warmth of any star, in a place so cold that even volatile substances could freeze solid. In our solar, its journey may have begun with a slow gravitational nudge. Maybe a passing star disturbed the outskirts of its home system, or a giant planet's orbit shifted just enough to fling it into space. Once free, it became a wand looping through spiral arms, weaving between clusters of stars, each pass changing its path just slightly. Some scientists speculate that such objects may act as natural couriers, scattering complex molecules between star systems. In their frozen interiors, protected from harsh radiation, organic compounds can survive astonishing lengths of time. If a comet like 3I Atlas were ever captured by a young planetary system and collided with a warm, rocky world, It might deliver these ancient molecules like seeds scattered by the wind. In this way, interstellar comets could play a quiet but profound role in spreading the building blocks of life across the galaxy. There is a quiet poetry in this idea. A comet, drifting alone for billions of years, might one day strike the surface of a lifeless planet, and in that collision, set something miraculous in motion, a spark. But 3I Atlas will not collide with any planet here. Its trajectory is a clean arc, a visitor merely passing through. That is why astronomers are racing to capture every bit of data before it's gone. For them, this comet is not just an object. It's a message in motion, one that may tell us something about the history of our galaxy itself. Future observatories like the Vera Rubin telescope are expected to detect dozens, maybe hundreds, of interstellar visitors each decade. But 3I Atlas is special. Its sheer size makes it easier to study in unprecedented detail, and its timing, coinciding with multiple active spacecraft, is perfect. It has arrived at a moment when humanity finally has the tools to listen carefully. Already, planetary scientists are planning how to use the next wave of data. They will map the comet's surface activity, chart its jets, refine its mass estimates, and compare them to models of comet formation. Each measurement, each spectral line, is like adding a brushstroke to a slowly emerging portrait. And in those brushstrokes, they hope to glimpse something beyond numbers, a story written in ice and silence, a fragment of another star's ancient tale carried across the galaxy and whispered into our night skies. As the months pass, 3I Atlas drifts slowly away from the sun, its tail fading like the last ember of a distant fire. The solar wind that once carved luminous streams from its surface now touches it only faintly, and the brilliant green coma that surrounded it near Mars begins to dim. To the naked eye, it disappears into the star field, becoming once more a ghost among constellations. But astronomers have not stopped watching. Far beyond the orbit of Earth, deep space probes and planetary spacecraft quietly turn their instruments toward a point of darkness, tracking the comet's retreat. Among them is JUICE, on its long journey toward Jupiter. The spacecraft's cameras wait patiently for the moment when 3I Atlas will pass within view, not close enough for a rendezvous, but near enough for a brief, precious window of observation. In those distant regions, sunlight is weaker, the shadows sharper, and the comet reveals a different character. Its activity slows. The furious jets of gas that once erupted from its surface become rare and quiet. What remains is the true, massive core, a monolithic traveler, unhurried, unaffected by anything but the gravity of the sun and planets. When JUICE's sensors finally capture it, the images will travel across hundreds of millions of kilometers, reaching Earth with a delay of hours. Scientists will gather in silent control rooms as the first frames appear, grainy at first, then sharper as they are processed. For a few moments, humanity will glimpse this ancient object from a new perspective, a dark shape gliding through the starry backdrop, a visitor from another system illuminated by our sun one last time. These moments matter because once 3I Atlas crosses beyond Jupiter's realm, the solar system's grip weakens. Jupiter's gravity will give it a final nudge, slightly bending its path, sending it outward along a new trajectory. It will not return. There will be no second visit. In the quiet mathematics of orbital mechanics, scientists can trace its future for millions of years. It will move into the outer darkness, through the scattered disk, past the edges of the Oort cloud, and eventually into the open interstellar medium again. There, between the stars, its journey will continue, untouched, unseen. Perhaps, in some distant future, another civilization will spot it crossing their sky. They might build telescopes to study it, just as we have. They might send spacecraft to meet it. Or perhaps it will remain what it has always been, a silent wanderer, carrying a story that no one fully hears. The poetic beauty of this moment is that we, for the briefest flicker of cosmic time, have shared a sky with it. Long before our species existed, this comet was already traveling. Long after we are gone, it will still be moving. Its passage reminds us that our solar system is not isolated. It is part of a vast galactic network, a river of stars and debris, through which ancient travelers flow like messages cast into an infinite sea. Astronomers know that after Atlas leaves, others will come. Some will be small, faint, fleeting. Others may be larger, stranger, perhaps even more ancient. With each one, our understanding of the galaxy will grow, and the night sky will feel a little less empty. But 3I Atlas will always remain special. It came at a time when our instruments were ready, when our curiosity was sharp, and when our stories about the cosmos were beginning to deepen. It offered us not just data, but a sense of scale, a reminder that the galaxy is alive with motion, and that even across unimaginable distances, paths can cross. And so, as it recedes into the dark, the comet leaves behind a kind of quiet legacy. It has changed how we look at the night sky. It has shown us that the boundaries between star systems are not walls, but open gates through which wanderers have always passed. Somewhere far beyond the planets, 3I Atlas continues its ancient glide, indifferent to the attention it received, carrying with it frozen stories that began before the sun ever shone. And beneath the dark, endless sea of stars, humanity watches and listens. When 3I Atlas finally fades from view, the sky does not grow quiet. In the months and years that follow, observatories, laboratories, and data archives continue to hum softly with activity. The comet may be gone, but it has left behind a trail of evidence, not in dust, but in measurements, spectra, and observations carefully recorded during its brief passage. In research centers across the world, astronomers begin the slow, patient work of unraveling its secrets. They analyze light curves to trace its rotation. They examine faint fluctuations in brightness to understand its surface. Each graph and spectrum is like a piece of a jigsaw puzzle scattered across disciplines: chemistry, physics, planetary science, astrobiology. From this scattered evidence, a story begins to take shape. One of the first breakthroughs comes from the chemical analysis of its coma, the cloud of gas and dust that surrounded it near Mars. Using data from Mars orbiters and Earth-based telescopes, scientists find unusually high levels of carbon dioxide and complex organic molecules, far richer than what is typical for comets born in our own solar system. These organics are fragile. For them to have survived billions of years suggests that 3I Atlas traveled through space with an unbroken cold shell, preserving ancient chemistry like a vault of frozen time. The second revelation emerges from dynamical modeling. Astronomers retrace the comet's path far into the past, following its trajectory backward through the galaxy. The simulations suggest that 3I Atlas may have come from a quiet region in the outer disk of the Milky Way, near a cluster of ancient stars that formed early in galactic history. Its orbit appears to have looped through the spiral arms multiple times, perhaps crossing the galactic plane again and again, each passage subtly reshaping its course. These models paint a picture of a traveler that has wandered for billions of years, brushing past countless stellar systems, drifting through star-forming regions, and surviving cosmic events that would erase lesser bodies. It is not just an interstellar object, it is a witness to galactic history. Meanwhile, planetary scientists studying its mass and shape uncover something equally striking. The comet's density is slightly higher than expected for a pure ice-dust mixture. This suggests that its interior may contain rocky or metallic inclusions, perhaps remnants of the environment in which it formed. It's possible that 3I Atlas began its life near the border between a star's icy outskirts and its inner rocky belt, a liminal zone where minerals and ices mixed freely. This mixture is rare and precious. It means that inside this comet might be minerals from a star system that no longer exists, carrying isotopic ratios unlike anything found in our solar system. Though we couldn't capture it physically, the spectral fingerprints it left behind are enough to confirm that we have, for the first time, studied material forged around another star in extraordinary detail. The implications ripple outward like gentle waves. Astrobiologists study its organic chemistry and realize that such objects could indeed act as natural couriers of complex molecules between star systems. Cosmochemists refine their models of galactic mixing, understanding better how material from one star system can eventually end up passing through another. Astronomers, inspired by the scale of its journey, begin planning for future missions designed to intercept the next interstellar visitor, not decades after detection, but within months. And as they work, something subtle changes in the way people talk about the galaxy. 3I Atlas becomes more than just a comet, it becomes a symbol of connection. A reminder that the stars are not isolated islands, but part of a shared, dynamic network. Comets like Atlas are the messengers of that network, silent travelers linking distant worlds through shared histories written in ice and stone. Years later, students studying astronomy will open their textbooks and find entire sections devoted to the discoveries sparked by this single object. It will be remembered not for spectacular displays in the sky, but for the depth of understanding it left behind. In that sense, its passing was not an end, but a beginning.